Hello students, myself Professor Snehal Arun Sagre. In today's session, I am going to discuss Introduction to Microcontrollers of subject Electrical and Electronics Engineering. So, in today's session, we will see microcontroller, but before proceeding to microcontroller, let us see microprocessor first. Microprocessor. So, what is actually a microprocessor? Microprocessor is a controlling unit of a microcomputer which is fabricated on a small chip capable of performing ALU operations. ALU is referred to arithmetic logical unit and which communicates with other devices connected to it. This is general diagram of microprocessor connection in which we could see microprocessor is being connected to input device, output device and to the memory. In microprocessor, there are concerned three most important parts. First, ALU. Second, register array. Third, control unit. So, initially, when the instructions are stored in the memory, they are in sequential order. Nextly, the microprocessor fetches those instructions from the memory and decodes it. After decoding, it executes the instruction till stop instruction is received. Later on, it sends the result in binary to the output port. Between these processes, the register stores the temporary data and ALU performs the computing functions. So in short, we can say microprocessor fetches, decodes and executes the instruction. Microprocessor consists of ALU, register array and control unit. So let us see one by one. ALU is a combinational digital electronic circuit which performs arithmetical and bitwise operations on the integer binary numbers. That is nothing but the data received from memory or an input device. Next, register. Register array consists of registers which are identified by the letters like B, C, D, E, H, L. Along with register, there is one more, that is accumulator. Lastly, control unit. The control unit controls the flow of data and instructions within the computer. There are some terms concerned to microprocessor as well as microcontroller. So let us see them. First, instruction set. It is a set of instructions that the microprocessor can understand. Next, bandwidth. It is the number of beats processed in a single instruction. Clock speed. It determines the number of operations per second the processor can perform. It is generally expressed in megahertz, gigahertz, and also it is said to be clock rate. Word length. It depends upon the width of the internal data bus, registers, and ALU. It may last from 8 bit to 64 bits. Next, data types. The microprocessor has multiple data type formats like binary, BCD, ASCII, signed and unsigned integers. Nextly, the features of microprocessor. Firstly, it is cost effective. Microprocessor chips are available at low prices. Next, size. The microprocessor is of small size, hence it is portable. Next, low power consumption. Microprocessors are manufactured by using metal oxide semiconductor technology, which has low power consumption. Versatility. The microprocessors are versatile as we can use the same chip in a number of applications by configuring the same software program. Reliability. The failure rate of an IC in a microprocessor is very low, hence it's reliable. Now let us start with microcontroller. Microcontroller is a small, low-cost microcomputer which is designed to perform specific tasks of an embedded systems, like displaying microwaves information, or it could be receiving remote signals. Next, block diagram. So in this we could see a block diagram concerned to your microcontroller. Firstly, we have a part of microprocessor unit that is set to MPU. Next, memory. Next, input output ports. And lastly, supporting devices. So, all of them are connected with respect to your bus system, which has the connection between each and every block. So, let us start. Firstly, MPU. MPU is responsible for fetching the instruction, decoding it, and finally executing it. It connects every part of microcontroller into a single system. Memory. The function of memory in a microcontroller is same as that of microprocessor. It is used to store data and program. A microcontroller usually has a certain amount of RAM and ROM or flash memories for storing program source codes. Your RAM is nothing but read or write memory. ROM is nothing but read-only memory. Next, parallel input or output ports. These ports are mainly used to interface or drive various devices. So the devices could be considered as LCDs, LEDs, printers, etc. to a microcontroller. Next, serial ports. Serial ports provide various serial interfaces between a microcontroller and other peripherals like parallel ports. Next, timers or counters. Either timers can be placed out or it could be a counter instead of a timer block. This is one of the useful functions of the microcontroller. They have more than one timer or a counter at a time in a system. The timers and the counters provide all timing and counting functions inside the microcontroller. The major operation of this section is to perform clock functions, modulations, pulse generations, frequency measuring, making oscillations, etc. This also can be used for counting external pulses. Next block is ADC. ADC is referred to analog to digital converter. ADC converters are used for converting analog signal to digital form. The input signal in this converter should be in analog form. Example, sensor output. And the output of this unit should be in digital form. The digital output can be used for various digital applications, example, measurement devices. Nextly, interrupt control. The interrupt control used for providing interrupt. So interrupt is referred to delay. For a working program, the interrupt may be external or internal, depending upon the programming concept. So in short, we can summarize a microcontroller is embedded inside of a system which is used to control a singular function in a device. It does this by interpreting data it receives from its input or output peripherals using its central processor. The temporary information that the microcontroller receives is stored in its data memory. When the processor accesses it and uses these instructions stored in this program memory to decipher and apply the incoming data. Then it uses its peripherals to communicate and enact with appropriate action. So this is all about microcontroller. Nextly, let us see its advantages. Advantages includes microprocessor is a microcomputer without any digital parts. Nextly, it has higher integration inside, which reduces cost and size of the system. Usage of microcontroller is simple, easy to troubleshoot, and system maintaining. Most of the pins are programmable by user for performing different functions. It could be easily interfaced with additional RAM, ROM, and input-output ports. Its load time required for performing operations. Nextly, disadvantages. So when it comes to microcontrollers have got more complex architecture compared to microprocessors. Only they perform limited number of executions simultaneously. They are mostly used in micro equipments. They cannot be interfaced with high power devices directly. Lastly, let us see the applications. They are used in biomedical instruments. Nextly, they are widely used in communication systems. They are also used as a peripheral controller in PC. Also, they are used in robotics and automobile fields.